In the last video, I showed you how to use the Cramer's rule for finding only two variables out of two given equations. Now in this video, I will show you how to use the Cramer's rule when you have a system of three equations and you have three unknown variables. Then how you will use the Cramer's rule to evaluate those unknown variables. When we have system of two equations and only two variables, unknown variables are given, then the matrix A formed will be of 2 cross 2 matrix. The dimension of the matrix will be 2 cross 2. Now here we have three equations and three unknown variables x1, x2 and x3. For that purpose, the matrix A will be of 3 cross 3. The dimension will be 3 cross 3. So let's write the matrix A first of all. The matrix A will be equals to the coefficients of unknown variables. The first equation will give us the first row, that is 3, 1 and minus 1. The second row, the second equation will give me my second row, the coefficients 1, 1 and minus 2. And the third equation will give my third row, minus 1, 2 and minus 1. Now I have to write my B matrix as well, that are the constants, minus 4 and 1. That is my B matrix. Now before proceeding further, we must know what is our A determinant. A determinant will be the determinant of this A matrix, that is 3, 1, minus 1, 1, 1, minus 2, minus 1, 2 and minus 1. Write it in determinant signs like this. Now how you can easily evaluate your determinant, that is of 3 cross 3. The dimension is 3 cross 3. So it is difficult as compared to finding the determinant of 2 cross 2 matrix. How you can find its determinant? I am expanding it through R1. Expanding by R1. You can expand it using R2. You can expand it using R3. I am expanding this matrix, this A determinant, through R1, row 1. So it will be 3 determinant. Formula minus 1. Formula minus 1 and the coefficient, second coefficient, that is 1. Determinant. Then minus 1 and determinant. So if you observe, if I am expanding it using R1, my first entry 3 is this one. Write a square determinant that will be of 2 cross 2. Formula minus 1 and this 1. And then determinant and this third entry, that is minus 1 and determinant. Now what entries will come in these determinants? First of all, if you have written your 3 here, then delete that column, delete that row. Delete your that row containing 3 and delete your that column containing 3. What is left behind? You are left behind 1 minus 2 and 2 minus 1. So write it here like this. Now the second entry, that is 1. Delete your this complete row, delete your complete column. You will be left with only 1 minus 1 minus 2 minus 1. Now third entry, delete your complete row, delete your complete column. You are left with only these terms. So it is 1, minus 1, 1 and 2. Now this you know very well how to evaluate where your 2 cross 2 determinant. This will be 1 time minus 1, formula minus times 2 times minus 2. That will be your plus 4. Then minus 1, 1 times minus 1, minus formula minus 1 times minus 2, that is 2. Minus 1, 1 times 2, formula minus times minus 1 into 1. So it will be this. After evaluating it, you will get here 9. If you observe, this is not equals to 0. So it means you can proceed further. If your determinant answer becomes equals to 0, then you will stop here by saying that your A matrix is singular, so you cannot find the solution. Now it is not singular, it is not equals to 0, so you will proceed further. What you will do, you will find x1, x2 and x3. How you will find your x1, x2 and x3? x1 will be equals to determinant divided by A determinant. y1 next variable is x2. x2 equals determinant divided by a determinant, and x3 equals determinant divided by a determinant. Now the question arises here, what comes in this determinant? This determinant will completely be the a determinant, but for x1 you have to replace your first column with b. For x2 you have to replace your second column with this b. For x3 you have to replace your third column with this b. How you will do it? You will simply for x1 write your complete matrix A as it is, just leave your first column and write the rest of the columns as it is, like this. Now what will be my first column here? My first column here will be my b value, like this. Now for the x2, write the complete matrix A but leave your second column empty and write the rest of the columns as it is. Leave your second column empty and write your rest of the columns as it is. Now what will come in your b in second column? Your second column will be filled up your b value, like this. Now in your third x3, write your A matrix completely, leaving your third column space empty, and fill your third column space with the b value, like this. So by evaluating these determinants you can find your x1, x2 and x3. So it will give you, now you can observe, complete A matrix but replace your first column with b value. For x2 replace your second column with b value. For x3 replace your third column with b value. Now you know very well how to evaluate the determinant for the 3x3 matrix by using the same pattern that I showed you here for the A matrix. After evaluating this value, you will get here complete answer for your numerator will be -9 and your A determinant is 9. So you will get here -1. Now here for x2, the value for your determinant will be equals to the 9, and you know that what is your A determinant? That is 9. So you will get here 1. Now for x3, the numerator determinant will be equals to 18 after evaluating using the same method that I showed you here for A determinant. Divided by A determinant is 9, so you will get here 2. So your x1 is equals to -1, x2 is equals to 1 and x3 is equals to 2. So this is your solution.